Hello everyone. In this problem, we are given a positive integer array and we have to find the largest subset such that for any pair of elements in the subset, one of them is divisible by the other. For example, if we have the numbers 1, 5 and 10 in the subset, if we take any two of them, we see that one of them is divisible by the other. For example, in this case, 5 can be divided by 1. Similarly, 10 can be divided by 1. And when we take 5 and 10 together, we see that 10 can be completely divided by 5. Let's look at the examples given. In the first example, when we consider 3 and 2, we see that they are not divisible by one or the other in any order, so they cannot be placed in any common subset. So the largest subset will either be 1, 2 or 1, 3. In the second example, when we consider all the elements as part of the subset, we can see that any pair of element will be divisible by one or the other. The whole array will be the largest subset. Let's try to come up with an intuitive solution for this. One important property is that whenever we are looking at two numbers in a pair, it's only the smaller element which can completely divide the larger element. It can never be the other way around. So whenever we are looking at any element in the array, it might make sense to compare them only with the smaller elements for divisibility. Hence, keeping the elements sorted in ascending order might be helpful. Let's try to look at another property using this example. When we consider 1000, we see that it can divide 10,000. And when we look at 100, we see that it can divide 1000. And since 1000 can divide 10,000 completely, we can notice that 100 will always divide 10,000. So this is kind of a transitive property where A divides B and B divides C, then A will completely divide C. Similarly, we can see that 10 divides 100, so 10 will divide both 1000 and 10 will also divide 10,000. Let's look at this larger example to come up with more ideas on how to solve this problem. We see that there are two major chains of numbers, one which are multiples of 3 and the other which are multiples of 2. Let's try to see how many chains we can start from 512 and which of them chain will be the largest. We see that there are no elements greater than 512, so 512 will only divide itself, hence the length of its chain will be 1. Similarly, we'll try for 32 on how many chains we can start from 32 and which of them will be the largest. We see that 32 can divide 512 completely, and since the length of the chain starting from 512 is 1, we can consider this to be a new chain, and the length of chain starting at 32 will be of length 2. Similarly, we can also store the next number in the largest chain, which will be 512 or 32. Now when we consider 9, we see that it cannot divide any of the larger elements. So the length of the chain starting at 9 will be of 1, and the chain will start and end at itself. Similarly, when we consider 8, we see that it can divide both 32 and 512. But since joining this with 32 will result in a larger chain, we'll use this, and the length of the chain starting from 8 will be 3. You can start to notice a pattern over here. Since we have all the elements sorted in ascending order, starting at each element, we can compare with all the elements on the right. And if our element completely divides any other number, we can consider it to be a part of the chain, and whichever will be the largest chain, that will be the length of the chain starting from that number. So for 3, we see that it can only divide 9. We can consider 3 and 9 to be part of a chain, and since the length is 1, and the length of the maximum chain starting from 3 will be 2. Similarly, when we start from 2, we see that it can divide all the green numbers, and since we are interested in only the largest chain, we'll connect it with 8, and the chain length will be of 4. And finally, when we look at 1, we know that it can divide everything on the right, and out of all the maximum chains that it can form, connecting it with 2 will result in the largest chain. Hence, the length of the chain starting at 1 will be 5. And once we are done, we know that 5 will be the length of the largest chain. And we know that one of these chain will start from 1. And we also have to keep track of the next number it connects to in the chain. And when we traverse that chain in that order until we cannot anymore, that will be our maximum subset. To handle the corner case, when we see an element that cannot divide any other element on the right, we'll point its next element to itself. And that will mark the end of a chain. This will be the same even for 9. One observation you can make is that this problem is very similar to a longest increasing subsequence, because for each number, we are comparing if it can divide the element on the right, and if it is true, we are using its own computed result and adding 1 to it. So if you have solved that one, this logic should be familiar. The time complexity of this would be O of n square, because we are starting from each element and then checking all the elements on the right. And the space complexity would be O of n, because for each element, we are only storing the length of the longest chain starting from there and also the corresponding next element. Let's implement our solution. The first thing that we'll do is sort our array in ascending order. Let's keep a variable to store the length of our array. Now let's define a one-dimensional DP storing the length of the maximum chain starting from any index. Similarly, we'll define another DP which stores the next element for the maximum chain starting from each number. So we'll initialize the chain starting and ending at the same index for each of the index. Now we'll start from the second last index in the array and go in a reverse order. And for each element in the right, we'll check if a current element completely divides it. So we'll start from the ith plus 1 index and go till the end. And we'll check if the right element modulo the current element is equal to 0. We'll now check if the new chain formed by joining j and I is greater than the chain already at I. We'll update the largest chain starting at I with the value at j and adding 1 to it. And for our current index I, we'll update the next element, which will be j. Please note that these two parts are very similar to the longest increasing subsequence problem. We check with all the elements on the right. If these two elements form a valid chain and the length of the new chain is greater than our current chain, we now update the value of our current chain and also store the next element. We are now done with our dynamic programming, and for our result, we have to start from any index which has the longest chain. We have to find the starting index of our longest chain. So we have to find in our DP array the index of any element which has the largest value. Please note that there can be multiple longest chains, and we are going to use the first occurrence of any longest chain. Let's define a variable for a result array. Now we'll start constructing our chain, and our current element will be our starting position. We'll also keep a previous element to check the end of the chain, and while the current element is not equal to previous, we'll keep going forward. And each time we'll add our current element to our output. And once we are done adding this number, our current element will now become the previous element, and the index of the next element for our current index will become our new current number. Please note that this loop will end at the largest number of our chain. This is because for that number, it will keep pointing to itself for the next element. Hence, the previous and the current will be the same. And once we have constructed our result array, we can return our result. We are now done with our solution. If you have any feedback or doubts regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching.